Right, so giant molecular compounds, huh? Sometimes also called giant covalent structures, they're made from tons of covalent bonds creating a structure or lattice within a molecule. Because the covalent bonds happen to be really strong, they make for high melting and boiling points. Other traits such as hardness and electricity conduction vary from material to material. So, to illustrate this point, let's move on to some examples. First up on the list, we have graphene. Graphene is extracted from graphite, the main material in pencil leads, so it inherits some traits from that, as well as some new ones with the altered structure. With the structure itself being quite unique, consisting of a single layer of carbon atoms extracted straight from graphite, which were only layers of graphene connected by weaker bonds, making for a fragile structure that is pretty easily broken. Graphene is very hard, making very high tensile strength because of the strong covalent bonds between each molecule. The same strong bonds also cause it to have very high melting points, but it doesn't really melt, instead sublimating, going straight from solid to gas at around 3,652 degrees Celsius. The material contains free-moving electrons, which makes it a conductor. In fact, it's one of the best conductors of electricity we have access to right now. Its various uses, such as in energy production and health, such as solar panels and drug delivery respectively, makes it one of the most versatile materials the human race has created so far. Diamonds, another allotrope of carbon, is recognized as another really strong material. This is mainly because of diamond's hardness and high melting and boiling points, 3,550 degrees and 4,830 degrees respectively, which stem from, again, the strong covalent bonds, though not being as strong as compared to graphenes. Its main commercial use is in jewelry and has an industrial use in cutting tools. Though it has no electricity conduction, it more than makes up for it in its sheer durability. Its structure is fairly conventional, with carbon atoms arranged in a pattern that leaves no spare free electrons, which leads to the previously mentioned lack of conductivity. Overall, diamonds are one of the most popular materials for fashion and factories.